Now I want to explain you the difference between synchronous and asynchronous mode of transfer. To understand this, I'll take a small example. You might have had this assembly gathering in your school, right, in which a PT, that physical trainer, he will be saying attention and stand at ease, and whenever he shouts attention and stand at ease, everyone is going to change the positions, right? So whenever he says attention, everyone will change the position in one go, and whenever he says stand at ease, everyone will change the position in other go, right? So like this, if everything is synchronized, if everyone is trying to do at the same time, or if everyone is trying to follow someone from the outside and take the actions depending on them, that is called as synchronous. In synchronous, we know when to do certain things. In asynchronous, there will be no monitor at all, right? So if you leave the kids like that in the ground, and if we ask them to play, they will not be playing synchronously, they will be playing asynchronously, right? So synchronous and asynchronous means if someone is monitoring you, then it is called generally synchronous. If all your actions are based on certain thing, then it is called synchronous. So why is it useful here is, the way we are doing this transfer, assume that there is a resistor, there are two resistors, this is resistor A and resistor B, and if both are using the clock, the same clock, let us say this is the clock is applied to both of them, so which means single source is coming, and they are connected to the bus. Okay, now if you want to transfer whatever is present in A into whatever is present in B, first you will try to select the resistor A, then the data which is present in A will come onto the bus. Therefore data in A is present at both these points, right? Which means in the bus the data A is present. Now at this time if you apply load input to this, then exactly at this particular point, whenever there is a positive edge, right? So whenever there is a positive edge, this particular transaction will happen, or this particular loading will happen. So one good thing about using a clock is, you will be sure that by this time the transfer of the data into B has happened, and so you can use the bus for the next transmission, right? So it gives you, by using a clock, it will give you exactly how much time you should leave the data on the bus, or when can you release the bus and use it for the next operation. Let us assume that there is no clock, right? Then we'll never be sure when the data has been moved to B, right? So why is this useful is, since it is all happening in the CPU, generally all the units which are present in the CPU will be using a single clock, and so everything will be synchronized. But then if you have source and destination at a larger distance, the distance between source and destination is, let us say, very large, then we cannot use the same clock. Let us say we have the clock here, right, and this clock is being provided to the source as well as to the destination. Even though you are providing it this way, there will be certain gaps between the clock here and between the clock there. It is called as clock skew problem. Clock skew problem, because since the distance from the clock to the source is very less, whenever there is a positive edge, that will immediately be seen by the source, but then the positive edge has to go after some time only the positive edge will be available at the destination. That is why in most of the cases we will not be able to operate or synchronize the communication using the clock. That is where we go with asynchronous mode of transfer. So simply put, if you are going to use a clock, that is called as synchronous mode, and if you cannot use a clock, then it is called as asynchronous mode. So if you didn't understand this, I'll just tell you one example. Let us say you are having this assembly ground. In a ground, all the students are standing in a lane, and there are various lanes, and the PT is standing in the front of the ground, and from the front, let us assume that he is shouting attention. Then the students who are standing in the front, they will be able to listen to this instruction and right away they will come to the position suggested. But then the students at the end, by the time they get the signal, there will be some delay. Therefore, all of them will not change their positions synchronously, right? They will be delay at the end. But we cannot allow such delays in data communication because there will be some data loss, isn't it? So are you getting this? The students who are standing in the front, they will immediately come to attention, but then the students who are at the end, they might not immediately listen to that instruction, or sometimes they might not get the signal at all till that point. Then what happens is they will just look at the students who are standing ahead, and whenever they change the positions, these students standing at the last will change the positions. Therefore, even though you try to give the single clock, it will not be possible if the distance is very large. Got it? So that is the reason we are going for asynchronous supply. So asynchronous transmission. So in asynchronous transmission, what happens is the data transfer between source and destination will not contain any clocks. Then there is a confusion, right? The confusion is simple. When is source sending the data to destination? Let us say source wants to send the data to destination, and so he has kept here the data, right? Now, for how long should the source let the data stay on the bus or stay on this communication channel? So first, destination should identify that some data has been sent, and then destination has to read the data, and till that point the data should be present in the bus, or the data has to be given by the source on the bus. So there are various problems which are going to be present there. So that is the reason there are various solutions here. So one solution is, instead of having the clock, they are having some solution like strobe signal. I hope you are getting this, whatever I am discussing here. So if you want to see the overview about what we are discussing here, we are talking about data communication. So what are the various modes in which we can communicate the data? Either you can go with serial or you can go with parallel, right? That depends on how long are you going to transmit the data. And in serial we have two types. One is synchronous, other is asynchronous. And in parallel also we have two types. One is synchronous and other is asynchronous. And wherever you see synchronous, it is done by using a clock, right? And wherever you see asynchronous, we don't have clock, we have various solutions, right? And now I am discussing about communication where this channel could be either serial or it could be parallel, right? Both of them, we are discussing both of them together. Now one way of doing this is using serial, using a strobe signal, and other way of doing it is using a handshaking method. So what does this strobe signal say is, if you have a source and destination, if you are going to propagate the data across this channel, along with this you are supposed to have one more line, and this line is going to tell the destination that I am placing some data. So what will source do is, let us say this is the strobe and this is the data line. For the simple, we can apply this data line, either it can be a single data line or it can be a parallel data line, but let's keep it simple. Let's assume that it is a single data line. And now what will source do is, on the data line it will place some data, and this is the timeline. Okay, on the data line it is going to place some data. So this doesn't represent that it is 1 or 0. I just assume that this particular part represents that there is some valid data in the data line, valid data, right? And after placing the data on the strobe line, it is going to say that, see, I have kept the data, and it is going to let the strobe present there for some time, and then he will take it off. right? See this, first we are going to put some data, the source is going to put some data on the data line, and after putting the data he is going to say that, see, I have put some data on this one. So whenever this destination sees this particular strobe right here, he is supposed to read the data from this one, right? And then the source will let the data stay in the data line for at least some time, by which our destination will be able to read the data. Got it? So this is the technique of strobe. So try to understand this one. We place the data and we switch on the strobe, and after that, after some time, we just pull off all these signals, and then we are ready for the next transmission. Got it? But there is a problem with this. The problem with this type of transmission is, you will be able to say that you have sent some data there, but then our destination is not able to say that, yes, I have copied the data. Sometimes the destination may be busy, or the destination is slow. Then what happens is, you are just letting the data stay there for some time based on the source assumption, right? And now if source pulls off the data before the destination even reads it, then there is a problem. That is why there has to be a two-way communication, and both of them have to say, yes, I read it, and then only we are supposed to delete it. Then how can we use it? So that solution is given by handshaking. In handshaking solution, they say that instead of having one line, we are supposed to have two lines, right? Let us say this is source and this is destination. Now there are two lines dedicated. One line should say that there is some valid data, and other line should say that data is accepted, and the other line, either it is a single line or a parallel line, it should actually contain the data, right? Now using this, we can solve the problem of this particular problem, right? The problem is, sometimes destination might not read the data. Then what we are going to say is, what we are going to do is, our source is going to place on the data line some valid data, and then in the line which is going to say that there is valid data, it is going to switch on, right? And both of them are going to stay like that. Okay, so first we are going to put the data, and after placing the data, you are going to say that, yes, I have placed the data via valid data. And now our destination will now read the data which is present in the data line, and it has to start the signal, yes, data is I have accepted the data. That is called as data acknowledgement line. So on the data acknowledgement line, our destination is going to say, yes, I have accepted the data. See this, first data is placed, and then data valid line is enabled, and after that data is being acknowledged by the data acknowledgement line, right? So immediately after seeing this one, you can delete this one as well as this one. Both of them will be deleted. So you are going to place it for some time, and then after seeing this, data valid line as well as data will come down. Got it? By using this method, it is called as handshaking, right? By using this method, we will be sure that data is being sent as well as data is being accepted, right? So this particular whatever example I have given you here and here, they are actually data transmissions initiated by the source, which means source wants to send the data and source is sending it. Sometimes what happens is, data can be requested by the destination as well. That is why these two lines are actually bidirectional. So sometimes destination can first raise the request for valid data, which means first this one will happen from destination, and then data will be sent by the source as a response, and then acknowledgement will be sent by the destination, right? So either a source can initiate the transfer or the destination can initiate the transfer, and these lines will be used appropriately. So these two are being used in many situations, and sometimes even without using this strobe and this handshaking also, people are able to transmit the data. So for that reason, we can use one other method. So strobe and handshake is simple, right? So let's use the other method. So we are not going to use strobe and we are not going to use handshake. Now in this method what happens is, let's talk about a serial line. So we are talking about asynchronous serial transmission. Now assume that one character is represented by 8 bits, and whenever you give a stroke in the keyboard, it is going to transmit 8 bits in a serial channel, right? Now how is this 8 bits going to be transmitted? So 8 bits have to be transmitted on a serial channel. So when you have a source and destination without this strobe and without all this, if we have only one serial channel, then how can we know that data is being transmitted? So we are going to follow a protocol. The protocol says that whenever you are not sending the data, always we are going to maintain the data line at signal number at signal 1, right? And before you start the data, if you want to start sending the data, you are supposed to make it to 0, right? And after that you are supposed to send the data based on whatever data it is. Let us say you want to send the data 110 11001, something like this. Okay, now 1 1 0 and then 1 and then 1 and then 0 and then 0 and then 1, right? And after you are done with the transmission, you are supposed to leave 2 or 3 blanks. That is why you will be sending 2 or 3 ones, and then you will be sending the next data. Got it? So the concept is, if you are sending a character using 8 bits, if you are not sending anything, always send 1. Then the destination will understand that nothing is being sent. And if you want to start sending some data, always send a 0 first, right? And after transmitting these 8 bits, you are supposed to put 2 ones at the end. Got it? So by using this type of transmission, serial data can be transmitted. So if you see this, for sending 8 characters, you are actually sending 11 bits. Sorry, for sending 1 character, you are actually sending 11 bits. If the question is like this, if a typist is typing at a rate of 10 characters per second, what is the data rate that our channel should support in bits per second? If you are sending 10 characters per second, each character is taking, see this, one character is taking 11 bits, therefore 10 characters will take 110 bits. If all the 10 characters have to be sent in 1 second, then 110 bits have to be sent per second. Therefore the total the data transfer rate has to be 110 bits per second. Got it? Okay, we shall see it now. So you should understand one difference here. Asynchronous transmission doesn't mean that we are not going to use the clocks at all. Okay, in asynchronous transmission also we have to use the clock, and we have to measure the time for each bit. For example, if you are going to say that high voltage is 1 and low voltage is 0, if I send a series of ones, then you have to understand, or you have to somehow get how many ones are present in that, and it will be done only when the clocks, both the clocks, when the clock at the source and the clock at the destination are synchronized, which means if both of them are going to have, if the clock at the source is going to show that this is the clock which is running, at the destination also they should have the same clock, right? So if one period at the destination for this duration, if it is 1, if it is representing 1, then the source and destination both have to show the same thing, right? Let us assume that there is a small difference in the clock timings, and the clock according to source is something and according to the destination is something, then there is a chance that you might miss out a bit. For example, if you are sending a series of ones, then there might be 4 ones according to the source, but according to the destination they might get 5 ones. The reason is the source and destination clocks are not synchronized, right? So how to understand the main difference between synchronous and asynchronous transmission is, in synchronous transmission we are going to have a common clock. In asynchronous mode, we are going to have the clocks, but then they are 2 different clocks, and somehow we have to again synchronize them, right? Both of them have to start generating the clock pulses at the same time, so that we can measure the bit durations exactly, right? So how can we measure that? These are 8 bits. Only we can do that when the source and destination clocks are showing the same types of clocks and they are synchronized, right? So whenever we have these rules, the first rule is, whenever always we are going to have 1 when we are not sending the data, and whenever we are sending the data we are sending a 0, right? So why this 0 is, whenever this 0 is ending at this part, both the source and destination will start their clocks at that location, right? Especially the destination has to start its clock at this duration, then only let us say this is the destination clock. Now according to the destination clock, this is 1, right? And again this is 1, and again this is 0, and again this is 1, and again this is 1, right? After reading 8, 6 are over, right? And again this is 0, this is 0, this is 1, right? So like that, again after reading 8 it will exactly know that yes, a character has been read, and the remaining ones it will leave off, right? So that is why we are going to have the clocks, but then the clocks are not the common clocks. So in case of asynchronous transmission, we have clocks but they are not common, right? But in case of synchronous, we are going to have the common clock for all the units. Got it? So in this way, without using the strobe and that handshaking protocols, we can use these bits and we can send them. So especially in asynchronous serial transmission, we are going to append some bits at the beginning of the character, and we are going to append some bits at the ending of the character. Therefore, the total number of bits that have to be sent are actually greater than the actual characters that we wanted to send. Even though we have one character is having 8 bits, if we have to send 100 characters, then we are supposed to send only 800 bits, right? But because of this method, we will be ending up sending 1100 bits. Got it? 3 bits will be sent extra for every character that has to be sent, but then we have to pay this fine, right? So this is the way it is being sent. And there are some other modes of communications where we are going to send the clock along with the data. They are called as these encodings. So Manchester and differential Manchester encodings will fall there. Anyway, we don't have the exact details of this data communication in the syllabus. Whatever is required, I taught you here, but I'm not going to get into the details of Manchester and differential Manchester. They are not required for us. They are for data communication students who are doing electrical and EC students. They need that in their gate. But for us in gate, we generally talk about only at this level, not the details of the in phase, out of phase. All those are not required. So I just made it simple and I explained you whatever is required. Questions will come only from this part. Okay.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So, first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.